Hello everyone, my name is Benjamin. Once again, a student of Victoria University. Today I'm back with our chemistry practical in our first session. It ended when I was communicating that we'll be having another practical session. So today we'll be looking at the effects of temperature on acetic acid and sodium bicarbonate, or we can call it the reaction between vinegar and baking soda. So this practical is aiming at investigating how temperature affects the rate of reaction between acetic acid and baking soda by measuring the gas production. So we'll need some materials, and the materials we'll need, we have what we call acetic acid. So acetic acid, we said it's the vinegar. Last time I showed you. We will need baking soda. This is baking soda. It's called sodium bicarbonate. Then we will need plastic bottles or small containers. So the plastic bottles, I have 1, 2, and 3. Then I have 3 plastic bottles. Another one we will need is the balloons to capture the gas. So also the balloons are available here. I'll be having the yellow balloon, pink and green. And then we'll have a thermometer. Sorry about this one, I'm not going to use the thermometer because I don't have it currently, but I'm going to estimate creativity. Now there will be creativity working, but I promise we shall have the best. Now we shall need water bath. So this water bath, I have also 1, 2, 3. So in this water bath, we'll need ice water. So ice water. So when you look at this, this is pure ice. This is a block of pure ice. So I'm just going to break off some particles to derive some ice water, or to get some small cubes for a practical session. So we have these ice cubes. So I'm selecting 1 container. We'll put our ice cubes. This is pure ice. It's very hard to break. So dear members, we are collecting the materials. So they said in the water bath, 1 should have ice water. I have ice blocks here, and they are gradually melting to give us the water. We want it at 5 degrees. Then from there we have another bath with normal water. So this water at room temperature. This is not hot water. This is normal water. normal water. So next we are fetching water which is hot, moderately up to 40 degrees, but so I don't know if you'll be able to see here. This water I'm drawing from here, this is hot water. You can see it's not hot. So it's relatively about 70 degrees. So these three are containing ice water, water at room temperature, and warm water. Then we are our procedures. We will need prepare day 3, water bath, ice water at 5 degrees, room temperature at 25 degrees, and warm water at 40 degrees. So we have here in our second one, then they say place 3 identical bottles, each containing a fixed amount of vinegar. Add the same amount of baking soda to each bottle. So we are going to measure, we need the same amount of vinegar in each bottle. So this is what we'll be doing. Please handle it carefully to avoid spilling. Yes, don't spill. I'm adding vinegar to the first bottle. So now that I don't have a measuring cylinder, at least I try my best to estimate. Yeah, so we always have the same amounts of the acetic acid in these bottles. So our second step is we are going to add the same amount of baking soda to each bottle and quickly stretch the balloon over the mouth to capture carbon dioxide. So we are going to see the chemical reactions of this, and this is our sodium bicarbonate or baking soda that we have to add. So they told us we are adding the same amount, and to achieve that we can use a spoon. We can use a spoon. Yeah, I have my wooden spoon here. So I'm going to use these 3 papers. So using my spoon, I want us to have approximately the same amount of baking soda. So I have 1 spoon here onto this paper. I have spoon 2 on the second paper. I have spoon 3 on the third paper. So why am I using the papers? We can use and add 1 small quarter, 1 small quarter, 1 small quarter. I'm using this because it is easy to fold and can ease my work when I'm putting. So I'll start with the first bottle. Remember, this bottle is I choose 1, then I add. The instruction is add the baking soda here. Immediately stretch. So Sorry, we've lost this carbon dioxide. Okay. So yeah, members, this is my practicals, and things are not running on my side very well, but yeah, here we go again. We are the science, we don't give up. Yep. So we got the first bottle. So I'm going to repeat for the other 3 bottles. I have to repeat. Make sure you prevent the leakage or escape. My people, always make sure you have water to rinse in case of contact with any chemical. Don't close your eyes with these vigorous experiments. So after this one, I'll immerse it in warm water. Have our first one immersed in warm water, and we are giving it some time. So members, the first experiment was shut down because of the spillages, so I'm back with these 2 again. This one in warm water. I think the reaction has stopped. We shall discuss the details of this. Dear members, so it is time for our experiment to show the results we are observing so far. So in this, when you are dealing with this in the assignment tells us to place each bottle in one of the water baths already installed. So from there, the time taken, we are measuring this time in seconds. So this balloon, I don't know if you are able to see, this one is in hot water, warm water. I think you see its size. This one is at room temperature. And this one is at is in the ice water. So when you look at these observations, if you look at the assignment, and when we have noted down there, so far this experiment is standing at different time intervals. If you are to look at very well, So in this case, this one was the first. It is in 95 seconds. This one was second, and it is in 60. No, and 64 seconds. This one is in 25 seconds. So 95, 64, and 25 seconds. And then in this case, we are looking at the observations between these two. You'll find that this one is it inflated very fast, indicating the impact of temperature. The higher the temperature, the higher the movement, or the faster the higher temperatures increases the reaction between sodium hydroxide and sodium bicarbonate and acetic acid. So in this mixture, you'll find that due to the vigorous reactions influenced by heat, there is a big size indicating a big production of carbon dioxide due to heat, which causes the faster molecule movements. And this one is indicated in the collision theory, that when the temperatures increase, they increase the speed of reacting particles, meaning that if the particles speed increase, the frequency of collisions increase, and also the number of collisions with enough energy to react. So you'll find that they react very fast, providing too much, releasing too much carbon dioxide, which is the gas that inflates the, which inflates the balloons. So when you look at this one is bigger than this one, and this one is slightly bigger than this one, because this one has lower temperatures. This is the 5 degrees. This one has moderate temperatures, so it has moderate reaction. Very slow, not fast, not too slow. So from there, I conclude by saying that temperature has a significant effect on the rate of reaction between vinegar or acetic acid and sodium bicarbonate, the one initially named as baking soda. So away from that, this one is a proof that as temperature increases, the reaction rate increases. And due to this, the kinetic energy and more effective collision, this one causes more kinetic energy. So the movement of particles becomes rapid, hence making the movement of carbon dioxide very fast and the accumulation very fast, hence coming out with something like that, or having a bigger size of the balloon blown or inflated. So in simple terms, when these two compounds are put together, they come up with, if acetic acid and sodium bicarbonate is put together, there will be sodium acetate formed, which is dissolved. It is a solution. It's an aqueous state, so it is just dissolved within the water there. We cannot see it, but can be tested using the chemical procedures. Then water can be also be observed, the liquid, and then so carbon dioxide gas that inflates the balloons. So that is my experiment. Benjamin Savakach, Victoria University. Thumbs up, and regards to my lecturer, Mr. Mark Ali, my colleague and colleagues of the chemistry class. So if you have any question you want to ask, let's meet in the comment section. You have realized that there were some spillages, so they always, even the instructions are here. They tell us that the safety procedure is here. They tell us field identification, safety context dimension. So they tell us to avoid, prepare the graph. So the safety tips: do not fill bottles to avoid bursting. So they are telling us, and handle vinegar with care to avoid spills. So in my case, I spilled some and they're here. So I'm going to deal with them to ensure they are cleared from the table to avoid any chaos or injuries. I remain Benjamin Sabakach. We'll meet in the next section.